Hey there, I'm Michael. I teach people about Python on the internet, and on this video, I want to tell you about something called PEP 572 assignment expressions. That sounds boring. What is that? Now let's call it by what us Python developers call it, the Walrus operator. The Walrus operator is awesome, and what it does is it allows us to combine creating a variable, assigning it a value, and testing it like in an if statement or a loop, something like that, all into one statement. And not only will this allow you to write cleaner code, or even allow you to understand certain values that you couldn't get at without using the Walrus operator. It's going to be awesome. You're definitely going to see some use cases you have not seen before. So let's dive in and write some code. Let's set out and just explore a simple example of the Walrus operator. Let's suppose you want to relive a little of that nostalgia from the early tech movies, war games. So let's imagine you're the computer here and you want to ask a question. So we know that our creator, his name is Professor Falcon. And we're going to ask, hey, user sitting at the terminal, what's your name? Easy input. What is your name? Now, if it's the creator, they're very playful and they want to play a game, right? So we'll say if name equal creator, and we'll just print, would you like to play a game? Now let's run it and see what we get. What's your name? My name is Michael. Nothing. Let's say we're Professor Falcon. Would you like to play a game? So perfect. However, look, we're capturing the value here and then testing it. Maybe we could do this in one line using the Walrus operator. Not necessarily suggesting that you do that in this case, but here's how it works. So we'll take the same code and we won't redefine creator. We'll just do the test. And instead of having the name here and the name there, in terms of the test, we can just change our equals. I like to say something like that, but we say colon equals. And it says if the name colon equals that, and we could even go and change this to print out the name. Greetings, name. We like to play a game. We'll put that in the other one too, just to be fair. Excellent. So maybe this is a little bit clearer. It shows we're grabbing this value here and we're assigning it in the name because we need to use it later, right? Ideally, or actually in this first version, we could have said, just if the name is that thing, we'll keep going. We don't have to create the name variable, but if we're going to use it again, we do. My name is Michael, and Michael. Let's try Professor Falcon. Greetings, Professor Falcon. Would you like to play a game? Same thing. All right, so here's the basic idea of the Walrus operator. And it's called that, of course, because if you turn it on its side, it looks like two eyes and those big tusks that a walrus has. All right, so maybe I would use it here. Honestly, I probably would still write the first code, but you'll see there's situations we're building towards that are absolutely going to require this. So let's put a little divider here and look at the next situation. Maybe this one will feel a little bit more realistic to you. We're going to work with some irregular expressions. So we're going to have this string. The video has a resolution of 256 by 1440 pixels. That's true for this video. And we want to capture out that value and that value using two groups. So the parentheses are going to say, here are some groups that we can then access later. So we could say this. We could say match equals r.match on the text. And we'll say if match and the length of match groups greater than or equal to 2, then we can print out something like, got to call that. We'll capture the width and the height. We'll say W, we'll put a little X here and say H. All right, let's comment out these for a moment so we don't have to keep answering them and run it again. Look at that. Given this string, we went and we captured those two numbers and we said the width is 256. That's one number we found, and 1440 is another. There's a couple of things not going great here. Look, we're actually calling groups 3 times. That would be nice if we could do that. If we could somehow, not call that many times, we could say groups equals match dot groups, but can you call that? there's an error. You can see this gets a little bit tricky. And try this again, but using the walrus. Well, the first one we could do is we could take this and move it right into there, kind of inline that, say colon equals this. And that's great, but we're also calling groups, groups, groups. What if we could just say G colon equals match.groups and then get the length of it? And then down here, we could say just G of 0 and G of 1. How's that work for us? Perfect. It's exactly the same. But now that it's so simple, you could kind of inline this, right? Make that G of 1. There we go. Run it again. Look, exactly the same output. Okay, now this compared to this is starting to make quite a big difference. This, I could absolutely see using this. And by the way, don't worry about that little warning there. G can be undefined. I don't think that's true. So in this case, not only is it cleaner, but we're also not calling .groups multiple times. I don't think that that's slow in regular expressions, but in some situations it could be. Let's look at a situation where it almost certainly will be. We have a user class. We have a function that, given a user ID, an integer, we may or may not get a user back. Either there's no user according to that ID or corresponding to that ID, in which case you get none, or we'll get that user back. Often, this would be very reminiscent of a database call. Okay, so that's an area where it could be slow. And here's a list of user IDs and some date we want to do a test or cutoff for. So here's what we're going to do in this scenario. We're going to say, I want to be given a list of user IDs and a date and say which ones of them, how many of those users have been active. And for the active ones, I want their actual user object back. Easy. Let's do a list comprehension. So what is the collection that we're going to loop over? We'll say for UID in user IDs. What do we want to get back? The user. So we're going to say get user by ID and give it the UID. But we also need to do a test. We'll say if, well, is there a user by that? Well, we're going to have to call. All we have to work with is user ID. So we got to call this function, get user ID by ID. And given that there is this user, not is it only enough to have the user, but they have to be active and or created. So we can call this again and say created date is greater than cutoff date. Yikes. So let's just print that out real quick. Well, here's two active users. Today is November 1st. And so sure enough, that one on Halloween and the day before, those are the ones who were active. And the other users, they're actually older or the IDs don't correspond to them. So these two users, this is the right answer. But remember, what if that's a database call or an API call? We're doing it 3 times. Oh my goodness. No, thank you. No thanks at all. So let's see about what this would look like if we use the Walrus operator. So it's going to be basically the same list comprehension and then the print statement. But here in this first part, we can say user colon equals. There's our comprehension. And we need to put parentheses around this because it's in the middle of this if statement like that. But once we've defined it, we're going to test first, does it exist? And then if it does, we want to do another test. So we can remove that second call. And then what we really wanted back in our list was the users that matched this test. They were in you could get them by the ID and that they were recently created. Well, we already have that user right there. So here's one of the biggest places that you will use one of these Walrus operators. I'm going to create an object and then I want to test that result. And then I want to maybe project it back, or I could even project back something like just the created date. So I want a list of the dates for when the users were created. I don't, but right, we're going to use that data further on. So if we run this again, exactly the same output. But if that is a database call, you don't want to do it 3 times. And even if you could, yuck, you don't want to write code like that. You want to write it like this. Here on line 74, go Walrus. Let's take another situation. Here we have a prompt we want to show to the user. Which action would you like to take? A, B, or C? And if you don't enter any of those, you just enter nothing. we're going to exit. And then we want to loop around, and long as they choose a valid action, A or B or C or C, 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 A, whatever order they want, we'll keep performing those actions. But if they ever enter just a blank line, we want them to exit out of the program. Awesome. Well, how's this going to work? So first we need to know whether or not they want to do a command before we enter this loop. So we'll first do a prompt up here, and then we're going to check, do our test here. Is it equal to nothing? Just the empty string. If it is not, we're going to print out you did a thing and then ask them again, go around and around and around, and then say bye now. What if we could do this using the Walrus operator? It's not going to surprise you though. We can, is it? Let's take the same thing. We don't need to duplicate the prompt text. So here we got our command equals, and we're just going to move that right into here. Put that into parentheses like this and change that to a colon. We don't need to ask it again inside the loop because every time through the loop we're doing the test. Every time we do the test, it asks the question. Here we go. Let's try again. Now here we're going to have to answer some questions. A, C, enter. That was the first loop. Here's the Walrus loop. A, C, enter. Boom. Exact same output, of course. But look how clean and simple this is. The command defined to be whatever we ask the user. If we strip it out and it's not the empty string, honestly, we don't really need this because of the way it's working, but just to be safe, I threw the strip in there. Well, there it is. Another way we can use the Walrus operator while we're doing a test in a loop, in this case, a while loop. Let's look at one more final use case here for the Walrus operator. This one you probably did not see coming. So we have these values here, just a set of numbers, 55, 7, 22, 200, 15, -5, -20, -10. There's some in there. They're kind of mixed up, some positives, some negatives. Now, Python comes with two very cool functions, one called any, and we can give it a list comprehension, which basically returns a set of true-false statements, and it'll tell us if any of those become true. So here, for example, we can say if any of the values are less than 0 for the values, the VN values, right? If that happens for any of them, then we have some negative numbers here. Not all of them, but at least one negative number was found. Otherwise, we can say, nope, no negative numbers, all positive. On the flip side of anything matching, we want to know that all things match. So here we can say all the numbers are less than 0. So yes, every single number is negative. Or in this other case here, we can say, no, there are at least some positive or some non-negative numbers that were not, they were not negative. Let's run this. Commented out the lines before. Well, I'll uncomment them and give them to you later. So here we have negatives. Yes, because we have -20, for example. We have at least one non-negative number, right? 7 or 15. But that's not what any and all tell us. They don't tell us that -5 was the first of any of the negative numbers. They didn't tell us that 55 was the first positive number that it ran into. It just said there is a positive number, not the positive number is this. So we can actually use the Walrus operator to capture that value as part of this. So let's try that. Using the Walrus, take exactly the same code, don't need to duplicate the values. And in our test here, what we're going to do is we're going to say first colon equal to that. We may need some parentheses here. And this will be the first one that matches the case where V is less than 0. And just to be safe, I'm going to put parentheses. This will be the first one that is a negative value. So we have negatives. We'll say the first is first. Let's run it, see what we get. Oh, how awesome is that? We have negative values. The first is -5. Let's look. Positive, positive, positive. Yup, you guessed it. -5 is the first one. Cool, cool, cool. Now on this one, we're trying to say all of them are negative. But if that's not true, the very first one that matches, that's going to be the one that breaks the case, the counterpoint of the statement, they're all negative. So nope, they're not all negative. Here's an example of one that is not like that. So we'll use the same trick here. And we'll say counterpoint colon equals this. Like that. Say all numbers are negative, or at least one non-negative number exists. For example, that one. We have negative numbers. The first one is -5. We have at least one positive number here, 55. Cool, huh? So we can use this capture of these expressions here to sort of set the value every time through. And as soon as it breaks, because any and all both exit early, as soon as one of them is true, we don't have to keep looking because any means at least one. So the first one, boom, we're out. Similarly for all, as soon as one is false, we break out and say, well, here's the false one. And so we've set the first and we've set the counterpoint example for our statements. So here's a way to get a little bit more out of any and all using the Walrus operator. I hope you enjoyed these examples. I'll put a link to the code in the description down below. There you have it, some amazing uses for the Walrus operator. How about that any and all, where you can capture the value that breaks or the first one that matches some condition. I didn't see that one coming before I started researching this project, and you probably didn't either. But mostly what we should use this for is for writing clean code that allows it to define the variables and set the value and test them. When it makes our code cleaner, we can also use it to make things faster, as we saw in the list comprehension. If you enjoyed this video, please subscribe and give it a like, and I hope to see you on another one. Thanks. Bye now.